Hey folks, I got a quick summary of kind of like the semester. This is about James Clerk Maxwell, and these are called Maxwell's equations. And they're really not all his equations. He just kind of put them together and kind of saw the relationships in them. So I will start writing them down, and you should recognize virtually all of them. So going in roughly chronological order, okay. The first one looks like this: double integral closed enclosed volume or enclosed surface of E dot dA equals what, as a review? Qn over epsilon naught. And whose law is this? Well, this is Gauss's law. Okay. Well, and then and this is Gauss's law for electric fields. Okay. Now there's a similar analogous equation in magnetism. Double integral enclosed surface of B dot dA equals what? Well, if you remember from our class discussion, this equals 0. Okay, and that's because magnetic poles come in pairs and such. And so no matter how many magnetic field lines you have going into a surface, you're going to have that many coming out. Okay. And this is basically Gauss's law in magnetism. Okay. The one from this chapter is Faraday's law, and that's closed path integral of E dot ds equals negative d magnetic flux dt. And that is Faraday's law. And then finally, we have this analogous equation in magnetism, okay, which is integral closed loop B dot ds, okay, and that equals mu naught In plus mu naught epsilon naught d electric flux dt. And this last one is called Ampere Maxwell. Okay, Ampere came up with, from what I understand in my history, most of this. Maxwell added the last bit. And I mentioned in the previous video, this is kind of important. So this says, hey, if you change an electric flux, you get a circulating magnetic field. And then if you have a changing magnetic field, you get a circulating electric field. And that's how, for instance, electromagnetic waves like light propagate through empty space. That was one of the understandings that came from these equations. Is scientists didn't understand how waves at all, like light or electromagnetic waves, infrared, ultraviolet, so on, how they could travel through empty space. As a matter of fact, they even made up an imaginary substance out in space called the ether, and they imagined the waves traveling through that. Well, eventually that was proven not to be there, not to exist. And so we had to come up with a way to explain how electromagnetic waves propagate. And these equations explain that. And there's more physics than this, but this is the beginnings of it. So this is virtually the entire semester of physics that we've learned. There are a lot of details in here. So, for instance, you got force. How does a push or pull happen? Well, that's QE, right? Plus QV cross B, right? So you have electric and magnetic force, okay? You might want to talk about energy, so like voltage is defined as potential energy per charge, okay? You might want to say how voltage relates to electric field, but that's kind of in Faraday's law. Change in voltage is negative the integral E dot ds, okay? But those are kind of details. The big picture stuff is this stuff here, okay? And then if you were to go and study more physics and the next level up, you would talk more. This would be the jumping off point would be these equations, and then you'd go from there, okay? So it's kind of weird. You see you see almost your entire semester of physics, and it's kind of summarized on about a half a page here, right? So it's a little goofy, but kind of cool too. So I hope you guys enjoyed this, and have a good one.